Hello everybody and welcome back. Root Beer here with question number 8 on the grade 8 2004 paper from the University of Waterloo. So what have we got? Two fair coins are tossed at the same time. What is the probability that they will both land as heads? Okay. So this is a very basic probability style question, but people can still get this thing wrong. Okay. So when you toss a coin, you either get heads or tails. And if it's a fair coin, you have 1 out of 2 odds of each, or the probability of 1 out of 2 of each outcome happening. Half the time it's going to be heads, half the time it's going to be tails. That's what we mean by fair. Probabilities are the same. Okay. So with a question like this, I think what I'm going to do is I'm going to make a little tree diagram of the possible outcomes. Okay. So, I think I'll just start on the next page. Well, actually, first let's talk about how people often get this wrong. So the possible outcomes here are they could both be heads, one could be heads and one could be tails, and they could both be tails. So a lot of people might write that out and realize, there's 3 outcomes. Heads is one of them. So 1 out of 3 outcomes. So that's 1 over 3, and that's D. Okay, that's what some people might think, or some people might rush through this question and jump to that conclusion, that our answer here is D, 1/3. This is not the case, and it's tricky because it's just because this is not how probability works. If each of those 3 outcomes, double heads, head tails, and double tails, was equally likely, then yes, 1 out of 3 would be the right answer. But 1 being head, 1 being tails is actually twice as likely as both of them getting heads. And by drawing my probability tree, I will show you why. So first, let's just make a little note to ourselves. No. Wrong. This is not how probability works. So now let's I'll keep let's flip the first coin. And then in a moment, we'll flip the second coin. Okay. So what I'm going to do is I'm going to create a probability tree. I start with nothing having been done, and there's only really the one way that can happen. Now the first coin could be heads, or it could be tails. Okay. 2 possibilities, equally likely, and both of them have a probability of a half. Now, no matter what the first coin is, the second coin he's sort of independent. He doesn't care what happened to the first coin, so he can also be heads or tails. Okay, with both outcomes. So either the first coin was tails, and then the second coin was heads, that sort of thing. And the second coin's probabilities are still a half. A half we can get heads there, a half we can get tails there, or a half heads, a half tails. Okay. So the way a probability tree works is if you want to follow a certain outcome, for example, getting both heads, you follow the tree from its start to its end and multiply the probabilities as you go. So it'll be a half times a half. The answer is actually going to be 1/4. But we can see right here that the number of ways that we can get heads and a head and a tail is twice as likely as the number of ways to get heads. There's only 1 branch from the start to the end that gets us heads, but there are 2 heads tails or tails heads that gives us an answer of 1 head and 1 tail. So it's a subtle concept, but it's something you need to master if you're going to continue on and continue learning about probability. But the number of ways to get heads, tails, there's more of them. It's not equally likely. A half of the time you're going to get a head and a tail. A quarter of the time you're going to get 2 tails, and a quarter of the time you're going to get 2 heads. And I believe that was answer E. But let's just double check. Yeah, E. 1/4. Okay. So that's about it. The question was just sort of, do you know probability? Do you understand probability? Can you reason like this? Or will you fall into the trap of they're all equally likely, so the answer is 1/3 D. Okay? So I don't have anything else to say here. Let's move on to question number 9.